Welcome to cryptography session. Today I am going to give an explanation for Vernam cipher. Another name for Vernam cipher is one-time pad. So there are four type of polyalphabetic substitution techniques are available, which are all namely Playfair, Vignir cipher, Hill cipher, Vernam cipher. Playfair contains a 5 cross 5 key matrix table. Vignir contains 26 cross 26 Vignir table. Hill cipher may be implemented with a key matrix and its inverse for encryption and decryption. And Vernam cipher implementation means the length of plaintext should be equivalent to length of keyword. So in the previous three algorithms, Vignir cipher only contains those type of conditions. The same condition will be applied for Vernam cipher. But the difference between Vignir and Vernam is, in a Vernam cipher, we should take a plaintext as a binary value. So if you take each letter, we can able to write its corresponding integer value, and that integer value should be written in a binary form, and we should do encryption and decryption operation. For those bit value calculations, we should use exclusive OR operation. So both exclusive OR operation is used at encryption side and also at decryption side. So in the given diagram, the left side portion is used for encryption and the right side portion specified a decryption mechanism. So if any plaintext is given, then first we should write the letters corresponding integer value, and that integer value should be converted into binary number. If any keyword is given, the same formula is applicable. First you should take the first letter, then we should convert it into its corresponding integer, then integer to binary form, and we should do exclusive OR operation. But only condition for using exclusive OR means the number of digits or number of bits in plaintext should be equivalent to number of bits in K. That means key. If those bits are equivalent, then only we can able to do exclusive OR operation. So the operation is specified as ciphertext Ci is equal to Pi exclusive OR Ki. Here I represents the ith bit value. So Pi means ith binary digit of plaintext. Ki means ith binary digit of keyword. Ci means ith binary digit of ciphertext. Then we should know the exclusive OR operation. So if A and B values are given, there are four possible values are possible: 0, 0, 0, 1, 1, 0, 1, 1. For the exclusive operation, if two bits numbers are same, the answer is 0. If two bits numbers are differed, the answer is 1. So for 0, 0, the exclusive OR operation give 0 answer. For 1, 1 also the same answer is there. For other operations, 1. So this is the exclusive OR operation. In this way, we should take each bit of plaintext that should be exclusive OR with the keyword. Then we get its corresponding ciphertext value. In decryption also, the same procedure will be applicable. For every decryption, we should take the ciphertext bit and its corresponding key bit is doing for exclusive OR operation. Then we can able to retrieve the plaintext bit from this operation. And one-time pad is represented as a random key usage. So the length of key should be equivalent to length of plaintext, like a Vignir cipher algorithm. So every time the key should be generated newly. And the same key is used for both encryption and decryption side, and it should not be discarded at a time. Binary operation is done at both encryption and decryption. So each new message requires a new key because of the same length. So that only the one-time pad is called unbreakable code. So for every new operations, we should take a new key value for doing the plaintext operations. So it produces a random output and the from that retrieved output we cannot able to find the relationship of its corresponding plain text value. So it is hard to deduct. So that only compared to other three polyalphabetic substitution technique, one-time pad is called as a strong encryption algorithm. This is the algorithm, this is the only algorithm for implementing binary operations in it. So let us take an example for implementing one-time pad. So it is the letter and its corresponding number format. The given plain text is enigma, keyword is keyword. So the length of plain text is 6, the keyword length is 7. So the same condition for Vigneous cipher, if the length of plain text is less than keyword, we should ignore last few letters of keyword. So I'm omitting the last letter. Now these letters are same. So I'm writing its corresponding number. So this is the number up to keyword. Then we should do exclusive OR operation. So if you take the first number 4, so you can able to write it as a 4-bit value 0100. 10 can also be written in a 4-bit form 1010. So the first letter of plain text, first letter of keyword will be taken and we should do exclusive operation. First bit only contains the same digits in it. So the other contains different letters. So the answer is 1110. 1110 means 8 plus 4 12, 12 plus 4 13. So the 13th letter is N. So the first ciphertext value is N. And then I am taking second letter of plain text and second letter of keyword. It is 13 and 4. You do the same exclusive OR operation. The answer is 1009. It is 9. So the ninth letter is J. So the second answer is J. Then you take 8. 8 means 1000. 24 means 16 plus 8, 24. The remaining values are 0. So I want to take the next immediate letter at 8. So I put 0. So the numbers are different. So 1, 0, 0, 0, 0. So I want to write it in a 4-bit form. So maximum 25 means we can able to write it in 5 digits format. So it is 8, 16. What is your 16th letter? It is Q. So I am writing it as Q. So next 1, 6. 6 means 0, 1, 1, 0. 22 means 16 plus 4, 20. 20 plus 2, 22. So the remaining values are 0. So same values are available. So 0, different value is 1. So 1 means Q. So for second one also it is Q. 12, 14. 8 plus 4, 12. 8, 4, 12. So if you do the operation 0, 0, 1, 0. Which means 2, second value is C. Then M, O. So 12 is written as like this. 12, 14. So for the 12, 14, the answer is given C. 8, 24, same answer. 6, 24, same answer. And 0, 17. So 0 means all 0. 17 means 16 plus 1, 17. So remaining digits are 0. So it is different. So 16 plus 1, 17. So 17th letter is R. So this is the answer. NJQQCR. So there are 6 letters. So you do the same decryption technique, which means that ciphertext value exclusive OR with K, we can able to get its corresponding plain text value. So this is a one-time pad or a Vernam cipher algorithm. So I am giving only one letter at a time for both encryption and decryption. So if you do exclusive OR for encryption operation and if you use the exclusive OR with the same secret key at the decryption side, the plain text will be retrieved. So it is one of the reason for choosing one-time pad as the best encryption technique. And difficulty means same length should be used for both plain text and key. So for that only there is a need of adjusting the plain text bits or a key bits. So it is not predicted as a perfect one. So the length of number of plain text will be varied with the key. So there is always a practical problem for making the large quantities of random key values, and the distribution of key and for protecting the key value is also a difficult process. So that one day we are not choosing one-time pad for best encryption algorithm. The next concept is transposition technique. This concept will be discussed in next session. Thank you.